This is Agile Systems, an AI provider. Welcome to Machine Learning series. Today's video is titled Datasets for Machine Learning Practice. This video is about different popular standard datasets used for practicing machine learning and deep learning techniques by data scientists. As this video is about datasets used in machine learning, so now we will explore different practice datasets as well as popular sources of datasets meant for learning, machine learning and deep learning. I will try to explain why datasets are important to solve any deep learning problem in as few words as possible and make it simple for you. So let's begin with the introduction to dataset. So dataset is this data source of artificial intelligence problem for which solution needs to be evolved and implemented. So the deep learning models are designed based on the traits and patterns available in the data source. Every data source before dataset gets created, it undergoes three processes. 1. Data exploration and profiling. Once the data is collected, it's time to assess the condition of it, including looking for trends, outliers, exceptions, incorrect, inconsistent, missing or skewed information. This is important because your source data will inform all of your model's findings. So it is critical to be sure it does not contain unseen biases. Point number 2. Formatting data to make it consistent. The next step in great data preparation is to ensure your data is formatted in a way that best fits your machine learning model. If you're aggregating data from different sources, or if your data set has been manually updated by more than one stakeholder, you will likely discover anomalies in how the data is formatted. For example, USD 5.50 versus $5.50. Consistent data formatting takes away these errors so that entire data set uses the same input formatting protocols. 3. Improving data quality. In this step, we implement automatic tests to ensure data quality. Some common tests include checking to see that there are no missing values, no erroneous, no realistic values, no duplicates, or no incurrent table joins. Additional tests for training and serving consistency, especially for forecasting problems. Depending on the machine learning model that you will be using, you may need to do additional transformation such as normalization and replacing the outliers. Data transformation is another part of data preparation or dataset preparation. This step is used to convert the raw data into specified format according to the need of the model. The options used for transformation of data are as follows. 1. Normalization. In this method, numerical data is converted into the specified range, that is, between 0 and 1, so that scaling of data can be performed. Second point, that is aggregation. The concept can be derived from the word itself. This method is used to combine the features into one. For example, combining two categories can be used to form a new group. Point number 3, generalization. In this case, lower level attributes are converted to a higher standard. Point number 4, data reduction. After the transformation and scaling of data duplication, that is, redundancy within the data is removed and efficiently organize the data. So as you can see now, preparing data is a time-consuming effort in machine learning development, but one that can determine the success of the project. Machine learning has very complex computation. It totally depends on how you get the data and in which condition. Based on the condition of the data, you start to pre-process the data and split the data into training and test model. So to get the hang of proper dataset generation, one has to understand the intricacies of the data or information. So initially, every developer or data engineer has to work on the public dataset, which are streamlined and fine-tuned to implement and practice machine learning model techniques. Each dataset is summarized in a consistent way. This makes them easy to compare and navigate for you to practice a specific data preparation technique or modeling method. The aspects that you need to know about each dataset are as follows. 1. Name, how to refer to the dataset. 2. Problem type, whether the problem is regression or classification. 3. Inputs and outputs, the numbers and known names of input and output features. Point number 4. Performance, baseline performance for comparison using the zero rule algorithm as well as best known performance if known. 5. Sample, a snapshot of the first 5 rows of the data. 6. Links, where you can download the dataset and learn more. There are various categories of public datasets available for practice based on the business use case. Here we can see there are 7 broad classified datasets, namely 1. Music datasets, 2. Natural images, 3. Artificial datasets, 4. Faces datasets, 5. Text datasets, 6. Speech datasets, 7. Recommendation systems dataset. Now let's see why dataset matter in machine learning. The simple answer to this question is because machines too, like humans, are capable of learning once they see relevant data. But where they are vary from humans is the amount of data they need to learn from. We can think of machine learning data like a survey data, meaning the larger and more complete your sample data size is, the more reliable your conclusion will be. Datasets help bring the data to you. Datasets train the model for performing various actions. They model the algorithms to uncover relationships, detect patterns, understand complex problems, as well as make decisions. Apart from using datasets, it is equally important to make sure that you are using the right dataset, which is in a useful format and comprises all the meaningful features and variations. Feeding right data into your machines also assures that the machine will work effectively and produce accurate results without any human interference required. So keep in mind that it is important that the quality, variety, and quantity of your training data is not compromised, as all these factors help determine the success of your machine learning models. Also, preparing data is a time-consuming effort in machine learning development, but one that can determine the success of the project. Hence, one has to first comprehend how the data set has to be structured by practicing machine learning techniques with public datasets which have already been validated by experienced community developers. So let's explore the open source datasets which are widely used by machine learning evangelists. Here is the list of popular datasets, good enough for the beginners to start practicing machine learning on their laptops. Each dataset is small enough to fit into the memory and review in a spreadsheet. All datasets are comprised of tabular data and no explicit missing values. Wine quality datasets. Wine quality dataset are the one that can be used for practicing classification and regression tasks of machine learning. So this dataset can be viewed as a pure practicing dataset for supervised machine learning tasks. The class are ordered and not balanced. For example, there are much more normal wines than excellent or poor ones. Outlier detection algorithms could be used to detect the few excellent or poor wines. The wine quality dataset involves predicting the quality of white wines on a scale given chemical measure of each wine. It is a multi-class classification problem, but could also be framed as a regression problem. The number of observations for each class is not balanced. Also, we are not sure if all input variables are relevant. So it could be interesting to test feature selection methods too. The number of instances are as follows. Red wine, 1599 instances. White wine is of 4898 instances. Number of attributes are 11 attribute input parameters plus 1 output parameter or output attribute. The input variables or input parameters are as follows. 1. Fixed acidity. 2. Volatile acidity. 3. Citric acid. 4. Residual sugar. 5. Chlorides. Free sulfur dioxide. 7. Total sulfur dioxide. 8. Density. 9. pH value. 10. Sulfates. 11. Alcohol. The output variable based on sensitive data is the 12 quality, scored between 0 to 10. The baseline performance of predicting the mean value is root mean square error of approximate 0.148 quality points. Now coming to the next data set, that is the PIMA Indians diabetes data sets, involves predicting the onset of diabetes within 5 years in PIMA Indians given medical details. This data set is originally from the National Institute of Diabetes and Digestive and Kidney Diseases. The objective of the data set is to diagnostically predict whether or not a patient has diabetes. Based on certain diagnostic measurements included in the data set, several constraints were placed on the selection of these instances from a large database. In particular, all patients here are females, at least 20 years old or PIMA Indian heritage. The type of data sets and problem is a classical supervised binary classification. The number of observations for each class is not balanced. Given a number of elements, all with certain characteristics, that is features, we want to build a machine learning model to identify people affected by type 2 diabetes. There are 768 observations with 8 input variables and 1 output variable. Missing values are believed to be encoded with 0 values. The datasets consist of several medical predictor, that is independent variables, and 1 target, that is dependent variable. Outcome independent variables include the number of pregnancies the patient has had, their body mass index, insulin level, age, and etc. The variable names are as follows. Number of times pregnant, plasma glucose concentration in 2 hours in an oral glucose tolerance test, diastolic blood pressure, triceps skin fold thickness, 2-hour serum insulin, body mass index, diabetes, P degree function, age, outcome class variable, which is measured in values of 0 or 1, where 268 of 768 are having value 1 and the others are having value 0. The baseline performance of predicting the most prevalent class is a classification accuracy of approximately 65%. Top results achieve a classification accuracy of approximately 77% using the following hyperparameters, namely instances, attributes, majority, minority, IR, training, testing, missing values. So the hyperparameters are instances whose value is 768, attributes whose value is 8, majority whose values are 500, minority is 760, IR is 1.87, training dataset size is 614, test dataset is 154, missing values is 0. For further details on this dataset, you can visit the website www.statcrunch.com/app/index.php !data ID equal to 1326952. Now coming to the next dataset, that is the Sonar dataset, involves the prediction of whether or not an object is a mine or a rock given the strength of a sonar returns at different angles. The dataset was contributed to the benchmark collection by Terry Sejnowski, now at the Salk Institute and University of California at San Diego. The dataset was developed in collaboration with R. Paul Gorman of Allied Signal Aerospace Technology Center. The task is to train a network to discriminate between sonar signals bounced off a metal cylinder and those bounced off a rough cylindrical rock. Some of the characteristics of this dataset is it is multivariate. The number of instances is 208. The other attributes are it is made of real data, and number of attributes run to around 60, and the missing values are not there, and so this dataset was contributed by Salk Institute as well as Allied Signal Aerospace Technology Center, and the file sonar.mines, which is part of the dataset, contains 111 patterns obtained by bouncing sonar signals of a metal cylinder at various angles and under various conditions. The file sonar.rocks contains 97 patterns obtained from rocks under similar conditions. The transmitted sonar signal is a frequency modulated chirp, rising in frequency. The dataset contains signals obtained from a variety of different aspect angles, spanning 90 degrees for the cylinder and 180 degrees for the rock. Each pattern is a set of 60 numbers in the range of 0.0 to 1.0. Each number represents the energy within a particular frequency band, integrated over a certain period of time. The integration aperture for higher frequency occur later in time, since these frequencies are transmitted later during the chip. The label associated with each record contains the letter R if the object is a rock, and M if it is a mine, that is metal cylinder. The numbers in the labels are in increasing order of the aspect angle, but they do not encode the angle directly. It's more like a binary classification problem. The number of observations for each class is not balanced. There are around 208 observations with 60 input parameters or input variables and one output variable. The variable names are as follows: sonar returns at different angles, and the class, these two are the variable names that are part of the data set. The baseline performance of predicting the most prevalent class is a classification accuracy of approximately 53%. The top results achieved by a classification accuracy of approximately 88%. So anybody who is using this data set should try to achieve these kind of results. Now coming to the next data set, that is the Banknote Dataset. The Banknote Dataset involves predicting whether a given banknote is an authentic given a number of measures taken from a photograph. The Banknote Dataset is a binary classification problem. The number of observations for each class is not balanced. There are around 1,372 observations with 4 input variables and 1 output variable. The variable names are as follows: variance of wavelet transformed image within bracket continuous, skewness of wavelet transformed image within bracket continuous, kurtosis of wavelet transformed image within bracket continuous, entropy of image within bracket continuous, class within bracket O for authentic, 1 for inauthentic. The baseline performance of predicting the most prevalent class is a classification accuracy of approximately 50%. So the user of this database should try for almost 50% accuracy. This data set extracted from the images that were taken from genuine and forged banknotes like specimens. For digitization, an industrial camera usually used for printing inspection was used. The final images have 400 by 400 pixels. Due to the object length and distance to the investigated object, grayscale pictures with a resolution of around 660 dpi were gained. The wavelet transformation tool were used to extract features from images. The attribute information or the parameters or the hyperparameters of these data sets is 1. Variance of wavelet transformation image, 2. Skewness of wavelet transformation image, 3. Kurtosis of wavelet transformed image, 4. Entropy of image, 5th one, class. Now coming to the next data set, that is the iris flowers data set. The iris flowers data set involves predicting the flower species given measurements of the iris flower. This is perhaps the best known database to be found in the pattern recognition literature. Fisher's paper is a classic in this field and is referenced frequently to this day. The iris flower dataset is a multivariate dataset introduced by British statistician and biologist Ronald Fisher in his 1936 paper, The Use of Multiple Measurements in Taxonomic Problems. It is sometimes called Anderson's iris dataset because Edgar Anderson collected the data to quantify the morphologic variations of iris flowers of 3 related species. This dataset became a typical test case for many statistical classification techniques in machine learning, such as support vector machines. It is a multi-class classification problem. The number of observations for each class is balanced. There are around 150 observations with 4 input variables and 1 output variable. The dataset contains 3 classes of 15 senses each, where each class refers to a type of iris plant. One class is linearly separable from the other 2. The latter are not linearly separable from each other. The variable names are as follows: 1. Sepal length in centimeter, 2. Sepal width in centimeter, 3. Petal length in centimeter, 4. Petal width in centimeter. 5. Class, whose permitted values are iris setosa, iris versicolor, iris virginica. The baseline performance of predicting the most prevalent class is a classification accuracy of approximately 26%. So any user of this dataset should try to have an accuracy of at least 26%. The predicted attribute, the output of this dataset, is the class of the iris plant. This dataset is free and is publicly available at UCI Machine Learning Repository. This dataset is a CSV file which contains a set of 150 records and 5 attributes. Now coming to the next dataset, that is Abalone Dataset. The Abalone Dataset involves predicting the age of abalone given objective measures of individuals. The age of abalone is determined by cutting the shell through the cone, staining it, and counting the number of rings through a microscope. A boring and a time-consuming task. Other measurements which are easier to obtain are used to predict the age. Further information such as weather patterns, location may be required to solve the problem. Predicting the age of an abalone from physical measurements is the sample of multi-class classification problem, but can also be framed as a regression too. So, using this dataset, you can try out either of the problems. The number of observations for each class is not balanced. There are around 4,177 observations with 8 input variables and 1 output variable. The variable names are as follows: the sex, male, female, and infant, a length, longest shell measurement, diameter perpendicular to length, height with meat in shell, whole wheat, whole Abalone, sucked weight, weight of a meat, visceral weight, gut weight after bleeding, shell weight after being dried. Rings plus 1.5 gives the age in years. So I'd like to repeat the variable names. The variable name 1, which is sex, has the values of male, female, and infant, that is M, F, and I. Variable 2 is length, so the longest shell measurement is entered for this variable. The variable name diameter, that is the third variable, has the perpendicular to the length value. Height, the fourth parameter or fourth variable name, has the values meat in shell. The fifth variable name whole weight is nothing but the whole Abalone's weight. Shucked weight is the value of weight of a meat. Viscera weight, that is gut weight after bleeding. Shell weight, that is the value of the weight after being dried. And the last variable name is rings. The value entered will be the number of rings plus 1.5, which gives the age of the Abalone in years. The base performance of predicting the most prevalent class is a classification accuracy of approximately 16%. The baseline performance of predicting the mean value is an root mean square error of approximately 3.2 rings. The original file is available in https://archive.ics.ucl.edu/ml/datasets/Abalone. Now coming to the next data set, that is the wheat seeds dataset. The wheat seeds dataset involves the prediction of species given measurements of seeds from different varieties of wheat. The examined group comprised kernels belonging to 3 different varieties of wheat, namely Kama, Rosa, and Canadian. 70 elements of each randomly selected for the experiment. High quality visualization of the internal kernel structure was detected using a soft X-ray technique. It is non-destructive and considerably cheaper than other more sophisticated imaging techniques like scanning microscopy or laser technology. The images were recorded on 13 by 18 cm X-ray Kodak plates. Studies were conducted using combining harvested wheat grain originating from experimental feeds explored at the Institute of Agrophysics of the Polish Academy of Sciences in Lublin. The dataset can be used for tasks of classification and cluster analysis. It is binary 2-class classification problem. The number of observations for each class is balanced. There are 210 observations with 7 input variables and 1 output variable. To construct this dataset, 7 geometric parameters of wheat kernels were measured. The variable names are as follows: 1. Area, 2. Perimeter, 3. Compactness, 4. Length of kernel, 5. Width of kernel, 6. Asymmetry coefficient, 7. Length of kernel groove, 8. Class, whose permitted values are 1, 2, 3. All of these parameters were real-valued continuous, that is, a real data set composed of 3 groups of wheat seeds classified into 3 different varieties. As you already know, it is Kama, Rosa, and Canadian. The variable area is having the values of area of seeds. The variable parameter will contain the value of parameter of seed. Compactness contains the compactness of the seed. Length contains the length of the kernel. Width contains the width of the kernel. And asymmetry variable will contain the asymmetry coefficient of seeds. Length of the kernel groove contains the length of the kernel groove. and varieties is a factor which classifies the seeds into either of them. That is, number 1 indicates Kama, 2 indicates Rosa, and 3 indicates Canadian. The baseline performance of predicting the most prevalent class is a classification accuracy of approximately 28% for this dataset. So the users of this dataset should be having at least 28% approximately. Now coming to the next dataset, that is Boston House Price Dataset. The Boston House Price Dataset involves the prediction of a house price in thousands of dollars given details of the house and its neighborhood. It is a regression problem. The number of observations of each class is balanced. There are 506 observations with 13 input variables and 1 output variable. The variable names are as follows. The CRM, that is per capita crime rate by town. ZN, that is proportion of residential land zoned for lots over 25,000 square feet. Indus, that is proportion of non-retail business acres per town. CHAS, CAS, that is Charles River Dummy variable. That means 1 if track bounds river, 0 otherwise. NOx, that is nitric oxide concentration parts per million per 10 million. RN, that is average number of rooms per dwelling. Age, that is the proportion of owner-occupied units built prior to 1940. DIS, weighted distance to 5 Boston employment centers. RAD, index of accessibility to radial highways. Tax, full value property tax per $10,000. PT ratio, that is pupil-teacher ratio by town. B, that is 1000 multiplied by BK minus 0.63 whole raised to 2, where BK is a proportion of blacks by town. LSTAT variable name is percentage lower status of the population. MEDV, that is median value of owner-occupied homes in $1,000. So these were the features or the input variables where the observations are captured, and using this data set, the baseline performance of predicting the mean value is the root mean square error of approximately $9.21 thousand. So the user of the database should be targeting to the same baseline performance, that is approximately $9.21 thousand. Now coming to the next data set, that is ionosphere. Data set requires the prediction of structure in the atmosphere given radar returns targeting free electrons in the ionosphere. That means this ionosphere data set is used for prediction of the structure in the atmosphere for targeting the free electrons in the ionosphere. This radar data was collected by a system in Goose Bay, Labrador. This system consists of a phased array of 16 high-frequency antennas with a total transmitted power on the order of 6.4 kilowatts. The targets were free electrons in the ionosphere. A good radar returns are those showing evidence of some type of structure in the ionosphere. Bad radar returns are those that do not show evidence of some type of structure in the ionosphere. Their signals pass through the ionosphere. The received signals were processed using an autocorrelation function whose arguments are the time of pulse and the pulse number. There were 17 pulse numbers for the Goose Bay system. Instances in this database or dataset are described by 2 attributes per pulse number, corresponding to the complex values returned by the function resulting from the complex electromagnetic signal. This dataset, that is ionosphere dataset, is used for binary classification tasks or binary classification problem. The number of observations in this dataset for each class is not balanced. There are around 351 observations with 34 input variables and 1 output variable. The variable names are nothing but 17 pairs of radar return data, and the one output variable or the predicted output variable is class, which is G for good and B for bad. The baseline performance of predicting the most prevalent class is a classification accuracy of approximately 64%, and the top results achieved a classification accuracy of approximately 94%. So users of this data should be targeting in the range of 64 to 94%. Now we will explore some more popular datasets briefly, which are also extensively used for deep learning techniques, namely but not for beginners. The first one is the Kaggle, a place to go for data scientists who want to refine their knowledge and maybe participate in machine learning competitions. Also has a dataset collections. Registered user can choose among 13,321 high-quality themed datasets. Kaggle is nothing but a data science site that contains a variety of externally contributed to interesting datasets. It has a search box with filters like size, file types, licenses, tags, which makes it easy to find needed datasets. Another nifty feature of Kaggle website is users can bookmark and preview the ones they liked. Another popular dataset is Amazon's Datasets. This registry is meant to help people discover and share datasets that are available via AWS resources. The URL for this is https://registry.opendata.aws. Another one popular dataset is archive.org datasets. This dataset collection consists of large data archives from both sites and individuals. Archived from Internet Archive, a web archiving service for cultural heritage on the web. Next popular dataset is UCI Machine Learning Repository. This is one of the oldest source of dataset on the web and a great first stop when looking for interesting datasets. Although the datasets are user contributed and thus have varying levels of cleanliness, the vast majority are clean. You can download data directly from UCI Machine Learning Repository without registration. It classifies the datasets by the type of machine learning problem. You can find datasets for univariate and multivariate time series datasets, classifications, regressions, or recommendation systems. Some of the datasets are UCI are already clean and ready to be used. The next popular dataset is Google Datasets. In late 2018, Google did what they do best and launched another great service. It is a toolbox that can search for datasets by name from Google's collection of public datasets. Their aim is to unify tens of thousands of different repositories for datasets and make that data discoverable. Well done, Google. In order to contribute to the broader research community, Google periodically releases data of interest to researchers in a wide range of computer science disciplines. Browse Google's library of open source projects, public datasets, APIs, and more to find the tools you need to tackle your next challenge or fuel your next breakthrough using Google Dataset. The next popular dataset is Microsoft Data Science for Research. The Microsoft Research collection of free datasets, tools, and resources. This collection of free datasets from Microsoft Research has advanced state-of-the-art research in areas such as natural language processing, computer vision, and domain-specific science. Download or copy directly to the cloud-based data science or virtual machine for seamless development experience. Another popular dataset is Awesome Public Datasets. A topic-centric list of high-quality open dataset is Awesome Public Dataset. This repository is automatically generated by Awesome Public Dataset Core. This is a great resource of dataset organized by topics such as biology, economics, education, etc. This list of a topic-centric public dataset sources is having a very high quality information. They are collected and titled from blogs, answers and user responses. Most of the dataset listed below in Awesome Public Dataset repository are free, however some are not. Most of the datasets listed in the Awesome Public Dataset repository are free, but you should always check the license requirements before using any dataset. Now coming to the government's dataset, namely Data.gov, UK Data Service, Eurostat, Indian government data. Now briefly I'll list out the highlights of these above mentioned government datasets. Data.gov, it is a dataset which has 540 sets of US open government data. Data.gov is also known as the home of US government's open data. It is fast and simple. It's generalized portal by US government. It has the data sets in various categories like agriculture, climate, ecosystems, energy, etc. At the time of writing this article, the Data.gov portal has around 190,000 datasets. Users are free to choose the appropriate datasets among more than 237 odd related to 14 topics. When looking for a dataset of a specific domain, users can apply extra filters like topic category, locations, tags, file format, organization, and their types and publishers. The other government data services are UK Data Service. This is the UK's largest collection of social, economic, and population data, and it's available on the website whose URL is www.ukdataservice.ac.uk. Another website which is having Europe's data service is Eurostat, which is the open data from Europe Union's Statistical Office. The Statistics Office of European Union provides high-quality stats about numerous industries and areas of life. Datasets are open and free of charge, so everyone can study them online via Data Explorer or download it in tab-separated format. The European Union Open Data Portal (EU ODP) provides access to an expanding range of data from the European Union, institutions and other European Union bodies. You can use and reuse these data for commercial or non-commercial purposes. So you can access these data or datasets from the website whose URL is ec.europa.eu/eurostat/data/database. Coming to the next one, that is Indian government data. Indian government data is nothing but the open government data platform of India. Its URL is Data.gov.in. It's a platform for supporting open data initiative of Government of India. The portal is intended to be used by Government of India ministries or departments, their organizations to publish datasets, documents, services, tools, applications collected by them for public use. The Data.gov.in intends to increase transparency in the functioning of government and also open avenues for many more innovative use of government data to give different perspective. Open Government Data Platform India is also packaged as a product and made available in open source for implementation by countries globally. The entire product is available for download at the open source code sharing platform GitHub. The Open Government Data Platform India has 4 major modules. They are data management systems, that is for contributing data catalogs by various government agencies for making those available on the front end website after a due approval process through defined workflow. The Content Management System module for managing and updating various functionalities and content types of the Open Government Data Platform India platform. The Visitors Relationship Management, this module for collating and disseminating viewer feedback on various data catalogs. Final module, that is Communities. This module for community users to interact and share their zeal and views with others who share common interest as that of theirs. So, Open Common Data Platform has these 4 major modules which can be utilized for machine learning using India's dataset. Moving on to a new category datasets, that is computer vision datasets. There are many computer vision or image datasets to choose from depending on what it is that you want your application to do. In machine learning, image processing is used to train the machine to process the images to extract useful information from it. Some of the prominent datasets are as follows. First, visual data, whose website URL is www.visualdata.io. If you're working on image processing, computer vision, or deep learning, then this website should be your source of data for experiments. Visual data contains a handful number of great datasets that can be used to build computer vision models. You can look for certain datasets by certain computer vision subjects such as semantics, segmentation, image captioning, image generation, or even by solutions such as self-driving cars dataset. The second computer vision dataset, that is ImageNet. The ImageNet's website URL is www.imagenet.org. ImageNet is a dataset of images that are organized according to the WordNet hierarchy. WordNet contains approximately 100,000 phrases, and ImageNet has provided around 1,000 images on average to illustrate each phrase. The third computer vision dataset is OpenImages dataset. OpenImages dataset's website URL is github.com/openimages/dataset. OpenImages is a dataset of almost 9 million URLs for images. These images have been annotated with image level labels, bounding boxes, spanning thousands of classes. The data set contains a training set of 9 million images, a validation set of 41,260 images, and a test set of 125,436 images. The fourth computer vision dataset is 10K US adult faces database. The 10K US adult faces database website URL is www.wilmabrainbridge.com/facememorability2.html. This database consists of 10,168 natural face photographs and several measures for 2,222 of the faces, including memorability scores, computer vision, and psychological attributes. The face images are JPEGs with 72 pixels per inch resolution and 256 pixel height. The fifth computer vision dataset is Google's OpenImages. Google's OpenImage website URL is storage.googleapis.com/openimages/web/index.html. OpenImages is a dataset of 9 million URLs to images which have been annotated with labels spanning over 6,000 categories. These labels cover more real-life entities, and the images are listed as having a Creative Commons attribution license. The sixth computer vision dataset is Visual Genome. This website URL is visualgenome.org. Visual Genome is a dataset of over 100K images, densely annotated with numerous region descriptions like girl feeding elephant, objects like elephants, attributes large, and relationship, etc. If you visit the website, you will get a much better idea about this website. The next dataset is Chronomy dataset. Chronomy dataset is home to nearly 2.5 billion time series data of 1,000 topics from more than 1,000 sources. Knomi provides efficient data exploration tools with datasets clustered by sources and topics. The search by topic can be narrowed down with sources and indicators filters. Datasets are also listed in alphabetical order. Knomi is the most comprehensive source of global decision-making data in the world. Our tools allow individuals and organizations to discover, visual, model, and present their data, the world's data, to facilitate better decision and better outcomes. So, watch out for the Knomi website also. The next dataset is Data USA. Data USA is a comprehensive visualization of US public data where you can explore, map, compare, and download US data. Data USA puts public US government data in your hand. Instead of searching through multiple data sources that are often incomplete and difficult to access, you can simply point to Data USA to answer your questions. Data USA provides an open source, easy to use platform that turns data into knowledge. It allows millions of people to conduct their own analysis and create their own stories about America, its peoples, places, industries, skill sets, and educational institutions, ultimately accelerating society's ability to learn and better understand itself. Now, let me list a few more categories of datasets based on the information types they have, namely music datasets, natural images, artificial datasets, faces, text, speech, recommendation systems. Let me elaborate one by one. First, music datasets. The best example for music dataset is pianoneedle.me. This site contains music files of different formats for all friends of classical music. The pieces are developed at a digital piano by means of a sequencer or a MIDI bass and then converted to audio formats. In addition, some score and audios showing the scores during playing are available. The archive is extended per minute. Second is the natural images. The best example is MNIST, handwritten digits, whose URL where you can access these images are yarn.lecune.com/exdb/MNIST. MNIST database of handwritten digits available from this page has a training set of 60,000 examples and a test set of 10,000 examples. It is a subset of a large set available from MNIST. The digits have been size normalized and centered in a fixed size image. It is a good database for people who want to try learning techniques and pattern recognition methods on real world data while spending minimal efforts on pre-processing and formatting. The third type of dataset is artificial datasets. The best example for these type of datasets is Arcade Universe. The Arcade Universe is an artificial dataset generator with images containing arcade games, sprites such as Tetris, Pentomino, and Tetronino objects. This generator is based on the O-Brulex Kaggle dataset generator. It's available on GitHub. For more on this artificial dataset, Arcade Universe, check this out on GitHub. Coming to the fourth type, that is faces. The best example for faces dataset is labeled faces in the wild. It has 13,000 images of faces collected from the web, labeled with the name of the person pictured. The labeled faces in the wild, a database of face photographs designed for studying the problem of unconstrained face recognition. The dataset contains more than 13,000 images collected from the web. Each face has been labeled with the name of the person pictured. 1,680 of the people pictured have 2 or more distinct photos in the dataset. The only constraint on these faces is that they were detected by Weiler-Jones face detector. Coming to the fifth dataset, that is text dataset. The best example for this is 20 news groups. 20 news groups is used for classification tasks and mapping word occurrences to news group IDs. The news 20 newsgroup dataset is a collection of approximately 20,000 newsgroup documents partitioned evenly across 20 different newsgroups. To the best of my knowledge, it has originally collected by Ken Lang, probably for his newsreader, learning to filter net newspaper. Though he does not explicitly mention this collection, the 20 newsgroups collection has become a popular dataset for experiments in text applications of machine learning techniques, such as text classification and text clustering. The URL for this is http://qwone.com/JSON/20 newsgroups. Check this out, it will be very interesting. The sixth type of dataset is speech dataset. The best example for speech dataset is TIMIT speech corpus, used for phoneme classification. The TIMIT corpus of read speech is designed to provide speech data for acoustic phonetic studies and for the development and evaluation of automatic speech recognition systems. TIMIT contains broadband recordings of 630 speakers of 8 major dialects of American English, each reading 10 phonetically rich sentences. The TIMIT corpus includes time-aligned orthographic, phonetic, and word transcription, as well as 16-bit 16 kHz speech waveform file for each utterance. Corpus design was a joint effort among Massachusetts Institute of Technology, SRI International, and Texas Instruments Incorporation. The URL for this website is www.ldc.upenn.edu/catalog/catalogentry.jsp !catalog ID is equal to LDC93S1. Seventh one is the recommendation systems dataset. The best example for recommendation dataset is MovieLens, managed by GroupLens. The two datasets of MovieLens is available on www.grouplens.org. The first dataset has 100,000 ratings for 1,682 movies by 943 users, subdivided into 5 disjoint subsets. The second dataset has about 1 million ratings for 3,900 movies by 6,040 users. GroupLens research has collected and made available rating datasets from the MovieLens website, that is http://movielens.org. The datasets were collected over various periods of time depending on the size of the set. Before using these datasets, please review their README files for usage licenses and other details. So in conclusion, from what I can observe from these datasets, it seems like there is a global trend towards making more and more data available and easily reachable to the research and machine learning community. This means you can download the data right now and explore the problem by implementing your own model or reproduce someone else from a paper or a blog post. So here's the next steps you could do after watching my video. That is, pick one dataset, grab your favorite tool. It can be Skyscale-Learn, R, or other machine learning tools. See how much you can beat the standard scores. Report your results in the comments below, or you can finally report them to your own blog post and add it to Kaggle or any data source websites. Finally, the best way to get started is to practice on datasets that have specific traits. I recommend you select traits that you will encounter and need to address when you start working on problems of your own, such as different types of supervised learning, such as classification and regression, different sized datasets from tens, hundreds, thousands, and millions of instances, different numbers of attributes from less than 10, tens, hundreds, and thousands of attributes, different attribute types from real, integer, categorical, ordinal, and mixtures, different domains that force you to quickly understand and characterize a new problem in which you have no previous experience. You can create a problem of traits to study and learn about, and the algorithm will need to address them by designing a program of test problem datasets to work through. So good luck to all of you who want to try all these datasets. And please update the results in the comments below. I'll be watching out this comment section as often as possible. Thank you. Have a nice day.